Friend zone ka na ba? Nasabihang pwede kang lumapit pero hindi makakalabit? Don't you worry, you are not alone. You are just like the rational functions. Find out in this video how friend-zoned people are just like the rational functions. This is RJ offering you fat math so that you will have fat brains. So in this video, you will learn how to graph a rational function and to find its domain, x-intercepts, y-intercepts, range, and the asymptotes of this rational function. Graphing rational functions. Rational functions are functions that can be expressed as ratio of two polynomial functions. So you will have a polynomial on the numerator and another polynomial on the denominator, provided that the denominator is not the zero function. Okay, so let us have our first example. Consider the rational function x plus 4 over x minus 2. So find its domain, vertical asymptote, the x and y intercepts, the horizontal asymptote, the range, and sketch its graph. So here, as what you can see, we have a polynomial on the numerator and another polynomial on the denominator. So we have here a linear function and another linear. So it's the ratio of two linear functions. So it's called a rational function. So let's go to the domain. What is the domain of the function? It is the set of all values that x can take. So as what you can see here, we have x plus 4 over x minus 2. So x minus 2 on the denominator. So only the value of x that will make the denominator 0 will be the value of x that is not allowed, okay, from the set of real numbers. So actually, all real numbers can be a value of x except for those that will give a denominator of 0 because the entire function will be undefined. So in this case, since the denominator is x minus 2, so that the expression should not be 0. So x minus 2 should not be 0, therefore x should not be negative 2. You just add positive 2 to both sides of the inequality here. Okay, so all real numbers except 2 can be the value of x. So we write that this way: x, or the set containing x, element of R, meaning to say real number x, such that x is not equal to 2, meaning to say all real numbers except 2. Or in interval notation, that is from negative infinity to 2, 2 is not included, that's why parenthesis here, union 2 to positive infinity, 2 is also not included here. How about the vertical asymptote? For the vertical asymptote, that is the vertical line that the graph approaches. Okay, so how do you find that? So make the rational function in simplest form, then find the value of a that will make the denominator 0. So the line x equals a is the vertical asymptote. So in this case, the given here is x plus 4 over x minus 2. That is already in simplest form. So we will just find the value that will make the denominator 0. So we found it in the domain here. So x is 2. So 2 will make the denominator 0. So the line x equals 2 is the vertical asymptote. So x equals 2. So the line x equals 2 is this. That's a vertical line that passes through x equals 2 here on the x-axis. So it's this one. So x equals 2 is an equation of a vertical line. Let's move to the intercepts. So the x-intercept is the y value, is the x value when y is 0. So that means to say that's the value of x where the graph passes through the x-axis. So what are you going to do to solve that? Just make y 0. So y is f of x, so make this 0 equals, and copy the rest. And then solve for x. So when will a quotient or a ratio be equal to 0? Of course, if the numerator is 0. So that will give you 0 equals x plus 4. Or if you want, you can multiply both sides by x minus 2. So x minus 2 times 0 is still 0. And then x minus 2 will be cancelled here. And then you will be left with positive 4. X plus 4. And then to solve for x, add negative 4 to both sides of the equation. So it's going to be positive 4 is going to go to the left side of the equation. That will give you negative 4 equals x, or x equals negative 4. So that is the x-intercept, negative 4. Meaning to say, on the graph of the given function will pass through the x-axis at x equals negative 4. So it passes through the point negative 4, 0. Y-intercept. Y-intercept is the y value when x is 0. So what we're going to do here is we will make x 0 and solve for y. Okay, so here the given is f of x equals x plus 4 over x minus 2. Just replace x with 0 and then find the value of y. So you will have 0 plus 4 over 0 minus 2. So 0 plus 4 is 4, and 0 minus 2 is negative 2, and 4 divided by negative 2 is negative 2. So the y-intercept is negative 2. So the graph of the function passes through the y-axis at y equals negative 2. So it passes through the point 0, negative 2. For the horizontal asymptote, the horizontal asymptote is a horizontal line that the graph approaches. Meaning to say that will be the value of the function as you make your x value decrease or increase without bound. So here is what you're going to do to find the horizontal asymptote. You need to look into the degree of the numerator and the degree of the denominator. So the degree of a polynomial is its highest exponent. So if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0, or simply the x-axis. But if the degrees are the same, therefore the horizontal asymptote is y equals a over b, where a is the leading coefficient of the numerator, while b is the leading coefficient of the denominator. The leading coefficient is the coefficient of the leading term. And if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. But that doesn't mean that there's no other asymptote, just no horizontal asymptote. So the degree of the numerator, since this is a linear function, x plus 4, the degree is the exponent of x. So highest exponent is 1, so the degree is 1. For the denominator, the degree is also 1 since the exponent of x here is 1. So the degree of the numerator and the degree of the denominator are both 1, so they are equal. So the horizontal asymptote is a over b. What is the leading coefficient of x plus 4? Of course, 1, because the coefficient of x here is 1. And then the leading coefficient of the denominator, the leading coefficient of x, the coefficient of x here is 1. So y equals 1 over 1. So that is 1. 1 divided by 1 is 1. So therefore, the horizontal asymptote is y equals 1. So y equals 1 is a horizontal line that passes through y equals 1 on the y-axis. So this is y equals 1. How about the range? The range is a set of all values that f of x or y can take. So as what you can see here, y equals 1 is a horizontal asymptote. So if you will give values to your x, you can never have a value of y that is 1. So the range here is the set of all real numbers except 1, because you cannot have a 1 here for your y value. So we write that as the set containing y, element of R, element of the set of real numbers, such that it is not equal to 1. So all except 1. So how does the graph look like? Or in interval notation, it's negative infinity to 1, union 1 to infinity. So the graph of that, you can just connect this to, and then you have to make your graph asymptotic to the asymptotes. So observe the graph that as you move here to the left, your graph will just keep on approaching y equals 1 but will never intersect it. If you will move here to the right as you approach x equals 2, the value of the function will just go down without reaching actually, will just go down and down, approaching x equals 2 here. Okay. And then as you move from the right here, your function will just approach x equals 2 but will never touch the graph. As you move to the right, it will just approach y equals 1 but will never touch it. So sad. So just like the rational functions, some of us have that experience that you can only get near, you can just get close, but you will never intersect, you will never meet. But that's life. Just like the rational functions, it's just fine. It's still beautiful. Look at the function. It's it's a pair of functions, one here and another here. Actually, this is called hyperbola. And one here is called one branch of the hyperbola and another branch of the hyperbola. So this function or this rational function has a hyperbola graph. Okay? So this is a common type of rational function. Let us have our second example. Consider the function f of x equals 5x over x plus 1. Find its domain, vertical asymptote, intercepts, horizontal asymptote, range, and sketch its graph. So the domain is the set of all values that x can take. So x can take any value except for the value that will make this denominator 0. So x plus 1 should not be 0, so x should not be negative 1. So the domain is set of all real numbers except negative 1. So this is how you write it. And then the interval notation for that is this one. So for the vertical asymptote, that is, you will find the value of a that will make the denominator 0. So as what we have found here in the domain, the denominator is 0 if x is negative 1. So x equals negative 1 is the vertical asymptote. So x equals negative 1, where do you think is the line? It's a vertical line that passes through x equals negative 1. So it's this line. Okay, that's the vertical asymptote. Meaning to say the graph later will approach this line but will not meet it. Intercepts. The x and the y intercept. X-intercept, x value when y is 0. So just make y 0. So make this f of x 0 and then solve for x. Okay, multiplying both sides by x plus 1, you will get 0 equals 5x. Okay, so when is 5x equal to 0? Okay, so you divide both sides by 5. So 0 divided by 5 is 0. So that is when x is 0. So y is 0 when x is 0. So the x-intercept is 0. So it passes through the origin. And then for the y-intercept, the y value when x is 0, so make this x 0. So you will have 5 times 0 over 0 plus 1. 5 times 0 is 0, and 0 plus 1 is 1. 0 divided by 1 is 0. So the y-intercept is 0. Okay? For the horizontal asymptote, okay, so we need to look into the degrees of the numerator and denominator. What is the degree of 5x? That's the numerator. The highest exponent of x, so 1. How about the highest exponent of x in the denominator? It's also 1. So these two are the same, so still we will use this horizontal asymptote. The horizontal asymptote is y equals leading coefficient of the numerator over the leading coefficient of the denominator. So the leading coefficient here of the numerator is 5. The leading coefficient here is 1. This is the coefficient of x. Coefficient of x here is 1. So 5 over 1. 5 is the leading coefficient of the numerator. 1 is the leading coefficient of the denominator. And 5 over 1 is 5. So y equals 5 is the horizontal asymptote. Is the equation of the horizontal asymptote. So that's an equation of a line, a horizontal line that passes through y equals 5 on the y-axis. So that's the horizontal asymptote. This one, horizontal asymptote. Y equals 5. So the range, if this is in this common type of rational function, the range will also take values, all real values except this for this asymptote here, that's 5. Okay, so y can have any real value except 5. And how do you graph that? So if it's the common type of rational function like this, linear over another linear, then it's just a pair of hyperbola, or you have a hyperbola. So it should pass through here. So you are expecting that the graph is going to be here and the other one is here, one pair. Okay, so how will you get that? Of course, by giving values. You get values of x. Let's say give a value of x equals 1, x equals 2, x equals 3, and so on. And you have to connect the points. Or you can simply use a graphing app in your cell phones or in your laptop. But if the form is like this, a linear over a linear, then it's just like the example number 1. Okay, so it will look like that, then that one. So it will approach the asymptotes but will never intersect. It will approach y equals 5 here. It will approach x equals -1 here. It will approach x equals -1. It will approach y equals 5. But will never intersect those lines. Example number 3. We have f of x equals -2 over 2x plus 3. As what you can see, it's a linear function on the numerator and another linear on the denominator. So the graph that we are expecting is the same as the 2 previous examples. So still, you are asked here to find the domain, the asymptotes, the intercepts, the range, and the graph. So let's start with the domain. So we should have in the domain any real number except the value that will make the denominator 0. So 2x plus 3 must not be equal to 0. So what value of x will make that 2x plus 3 equal to 0? So solve the equation, the inequality in this case. So you can transfer this to the other side. It will become -3. Divide both sides by 2. You will get x should not be -3/2. So for the domain, it can be any real number except -3/2. So it's always like that for a rational function. The domain is the set of all real numbers except for the value that will make the denominator 0. So in interval notation, that's from -∞ to -3/2. Okay, open here, meaning to say it's not included. Union -3/2 to +∞. So for the vertical asymptote, it's automatic that the line x equals -3/2 is the vertical asymptote. So how does that look like? So -3/2 is -1.5. So it's this vertical line. For the intercepts, for the x-intercept, make y 0. So 0 equals -2 over 2x plus 3. Multiplying both sides by 2x plus 3, you will get 0 equals -2. Can 0 be equal to -2? Of course not. So that is impossible. Meaning to say, if you will get that in your solving, you will conclude that there is no x-intercept. Meaning to say, the graph doesn't pass through the x-axis. So no. Please take note that having no x-intercept is different from having an x-intercept which is 0. In this case, there's really none. So for the y-intercept, make x 0. So you will have, or you will just replace x here with 0. So -2 over 2 times 0 plus 3. So -2 over 2 times 0 is 0. So 0 plus 3 is 3. So -2/3. So it will pass through -2/3. So y-intercept is -2/3. So somewhere there. Okay. For the horizontal asymptote, you have to look at the degree. So what's the degree of the numerator? Here, 0. There's no x, meaning to say the degree is 0. Okay? Highest exponent of x in the numerator, 0. There's no x there. And then for the denominator, highest exponent of x is 1. So the degree of the denominator is 1. So when the degree of the numerator is less, because 0 is less than 1, then the degree of the denominator, you will have y equals 0 as the horizontal asymptote. So that is a horizontal line that passes through y equals 0, or simply the x-axis. So the x-axis. So for the range, it's the same. All real numbers except 0, except the one here in the horizontal asymptote. So the graph will look like this. Okay, since we know that the y-intercept is already here, so it should pass that. Okay, y-intercept is part of the graph. So you should let your graph pass through the intercepts. Okay, so the pair of that is this one. Okay. Example number 4. Consider the function f of x equals 6 over 3 minus x. Same questions. Okay, so for the domain, so all real numbers except the value that will make the denominator 0. So transfer x to the other side, you will have x is 3. So x should not be 3. So any real number except 3. And then for the vertical asymptote, automatic that x is equal to 3 is the vertical asymptote. So x equals 3 is this line, x equals 3. For the x-intercept, make y 0. So 0 equals 6 over 3 minus x. So 0 equals 6 still, not possible. So no x-intercept. So the y-intercept, just make y, just make x 0 and solve for y. So make this x here 0. So 6 over 3 minus 0. So that's 6 over 3. So that's 2. So 2 is the y-intercept. So so the graph will pass through the y-axis at y equals 2. So here, y equals 2 at y. And then for the horizontal asymptote, we need to look into the exponents of x. Highest exponent. For the numerator, no x, so the degree is 0. For the denominator, highest exponent of x here is 1. So 0 is less than 1, therefore the horizontal asymptote is y equals 0. So since the horizontal asymptote is y equals 0, the range will follow that it can take any real numbers or any real number except 0. So the graph should pass through this, so it should be like this. So the graph will be that and this. Okay? So for this common type of rational function, linear over linear, the graph is always this, hyperbola. Let us have our fifth example. Consider the function f of x equals x squared minus 2x minus 3 over x squared plus 2x minus 8. Okay, same questions. And then this time the given is still a rational function but ratio of two quadratic functions. So for the domain, we need to find values of x that will make the denominator 0. So x squared plus 2x minus 8, the denominator should not be equal to 0. So when will that be 0? How do we solve a quadratic equation? So same, we will factor. So factoring this, x squared plus 2x minus 8, we will get x plus 4 times x minus 2. So these expressions, the product of these two will be equal to 0 if one of them is 0 or both of them are 0. So that is when x plus 4 is 0 or when x minus 2 is 0. So x plus 4 is 0 when x is negative 4 and x minus 2 is 0 if x is 2. So these values of x are not allowed in the domain because they will make the denominator 0, hence our rational function undefined. So we restrict the domain that it can be the set of real numbers except these two values. So set of all real numbers except negative 4 or negative 2. Okay, so in interval notation, you have to write it this way. Negative infinity to negative 4, union negative 4 to 2, union 2 to positive infinity. For the vertical asymptotes, this time we have 2. Since we have two values of x that are not allowed, So we will also have two vertical asymptotes. So those are x equals -4 and x equals 2. So x equals -4 is this, and x equals 2 is this one. For the intercepts, for the x-intercept, make y 0. So make this 0 and then solve for x. So this will be 0 if the numerator is 0. And then factor. What are the factors of x squared minus 2x minus 3? Answer? X plus 1 and x minus 3. Okay, so when will the product of x plus 1 and x minus 3 be equal to 0? If one of them is 0 or both of them are 0. So that's when x plus 1 is 0 or x minus 3 is 0. So x plus 1 is 0 when x is -1, and x minus 3 is 0 if x is +3. So the x-intercepts are -1 and +3, meaning to say the graph of the function passes through the x-axis twice at -1, 0 and at 3, 0. For the y-intercept, just make x 0, so you will get 0 squared minus 2 times 0 minus 3 over 0 squared plus 2 times 0 minus 8. This one. This is 0, this is 0, this is 0, this is 0. So you will be having -3 divided by -8, or that is +3/8. So the graph will pass through the y-axis at +3/8. There. So this is 3/8. For the horizontal asymptotes, there's only one. For the horizontal asymptote, we will look into the degree of the numerator. Since this is quadratic, the highest exponent of x is 2, so the degree is 2. For the denominator, the degree is also 2, and the degrees are equal. So if they are equal, we have to use this one. The horizontal asymptote is y equals a over b. What's the leading coefficient here? The leading term is x squared. What's the coefficient of x squared? 1. Okay. The leading term here is x squared. What's its coefficient? Also 1. So the horizontal asymptote is 1 over 1. I mean, y equals 1 over 1. So y equals 1. So y equals 1 is a horizontal line that passes through 0, 1 here. Okay? So how are you going to graph that? Of course, you have to make it pass through these points that we have identified. So in this case, you will be needing more points so that you can graph this. Or you can use an aid of a graphing calculator or a graphing app. And if you can give points for this or x values and solve for the y, the graph of this will look like this. Okay, so as what you can see here, we still have a pair of hyperbola here, this and this, but this time we have another part here that passes actually through the horizontal asymptote here, this middle part. Okay, so you will get this graph by giving values for x and solving for y and plotting the points and connecting them. So, so as what you can see here, if you will look into it, the range is, okay, from, it will still extend here going down and down. So it's from -infinity, and then it goes up there, up and up to +infinity. So there's no restriction here. Y can take any value. Okay, so any real number. So for this case, if you only have this and this, it will be a set of real numbers except 1. But since we have this part here, and it has a -1 value here for y, so the range is the set of all real numbers. Example number 6, we have f of x equals 3x squared over x plus 4. This time, as what you can see, the degree of the numerator is greater than the degree of the denominator. Here is degree 2, here is degree 1. This is quadratic, this is linear. So ratio of a quadratic and a linear function. So let's look at how the graph looks like. So the domain, just find the value that will make the denominator 0. So that's not included in the domain. So the domain will be the set of all real numbers except -4. For the vertical asymptote, automatic, that it's x equals 4. You have to make sure, though, that this expression here, this rational expression is in simplest form. Okay? So if it's in the simplest form, then automatic it's x equals -4. And then for the intercepts, by the way, x equals -4 is this line. For the intercepts, for the x-intercept, make y 0. So that is 0 if the numerator is 0. So divide by 3, 0 equals x squared, take the square root, so x equals 0. So the x-intercept is 0. So here. And then for the y-intercept, of course, if the x-intercept is 0, the y-intercept is also 0. It's always like that because it passes through the origin. So y value when x is 0, so make x 0. So 3 times 0 squared over 0 plus 4, that's going to be, this is 0 times 3, 0 over 0 plus 4, that's 4. So 0 over 4 is 0. But actually, if you know that the x-intercept is 0, the y-intercept will automatically be also 0 because what they call this, it passes through the origin. Horizontal asymptote. So for the horizontal asymptote, you have to look into the degrees of the numerator and denominator. This time, the degree of the numerator is 2. The degree of the denominator is 1. The degree of the numerator is greater than the degree of the denominator, so there is no horizontal asymptote. None. Okay? But actually, if you will go into basic calculus later on in graphing functions like this, there will be an asymptote for this that is obtained by actually dividing this, and what they call this, you will get 3x squared divided by x plus 4. You'll get something like 3x minus 12 plus the fraction part. So that y equals 3x minus 12 will be the oblique asymptote. So it's also an asymptote, but it's a slanting line, not horizontal nor vertical. So it's called an oblique asymptote, which is beyond the general mathematics. So let it be like that. For sure, your teacher will not ask you anymore of the range of this function and to sketch its graph. But for this case, in this video, I will give you the graph of this function. So if you will if you will get the derivative of this function to analyze if it's increasing or decreasing, and finding the critical numbers, you will be able to identify that the graph is like this. But there's a pair for this down here that we cannot see anymore because of the limited Cartesian plane. This also has a pair. And for the range, it can take any value from 0 to positive infinity. And then for the bottom part, the pair of this, that's from negative infinity until negative 48. And you can identify the range and the graph of this function in basic calculus. Okay? If you will analyze the signs of the derivatives and identifying the critical numbers. So that's it for example number 6. Let us have our last example, the 7th example for this video. So we have here a function a rational function f of x equals x squared plus 5x plus 6 over x plus 2. Find the domain, asymptotes, intercepts, range, and sketch the graph. So for the domain, find the value of x that will make this denominator 0, and that will not be included in the domain. So x plus 2 should not be 0, so it should not be negative 2. So any real number except negative 2. So for the vertical asymptote, make the rational function in simplest form, then find the value of a, find the value a that will make the denominator 0, then the line x equals a is a vertical asymptote. So we have to check, is this already in simplest form? So we need to find out. Let's see. X squared plus 5x plus 6 can be factored. It can be factored as x plus 2 times x plus 3. And then you will see here that we have x plus 2 on the numerator and another on the denominator, and that can be cancelled. And you will be left with f of x equals x plus 3. So actually, this function is just like the linear function f of x equals x plus 3, provided that the domain does not contain negative 2, or provided that x is not equal to negative 2. So we are expecting here also a graph that is a line that has an equation y equals x plus 3. So since that's the case, there's no vertical asymptote for this. Okay, so because we cannot identify a value of a that will make the denominator 0, because the denominator here, in the simplest form, the denominator is already 1. So no vertical asymptote for this example. For the intercepts, okay, for the x-intercept, make y 0. So that is x, this is already our new function here. So make this 0. So 0 equals x plus 3. So x equals negative 3. So the x-intercept is negative 3. It passes through negative 3, 0. For the y-intercept, y value, when x is 0, so make x 0. So that's going to be y equals 0 plus 3. So 0 plus 3 is 3. So the y-intercept is 3. So it passes through 0, 3. Okay, as what we have said a while ago, we are expecting here a line. And to graph a line, it is sufficient that we have 2 points, because we will just connect these 2 points and we will have our line. So the graph of this function, for the horizontal asymptote, we don't have, because the degree of the numerator is 2, degree of denominator is 1. 2 is bigger than 1, therefore there is no horizontal asymptote. So for the range, that's a linear function. So it can be any real number, except of course for the value of y when x is negative 2. When x is negative 2, the value of y is negative 2 plus 3, 1. So this 1 is not included also in the range. So the set of all real numbers except 1 is the range of this function, and the graph looks like this. As what you can see, there's a hole here. This hole is the point negative 2, 1. When x is negative 2, y is 1. There's a hole here. That means this point is not part of the graph. So the graph of this function is just a line with a hole. Meaning to say, this hole here, negative 2, 1, is not part anymore of the graph of this function. Okay, so that's it. So, how are the friend zone people are just like the rational functions? So in rational functions, the value or the graph of the function can approach a certain line but will never meet it. Same with friend zone people. They can just come near or go near, but they will never intersect. Hanggang friend ka lang. So hanggang dyan ka lang,
rational function. Or maybe some of you are just like the asymptotes. They are the ones giving the limitations. I hope you learned in this video how to graph the rational functions, how to find the domain and range, the intercepts, and the vertical and horizontal asymptotes of the rational functions. Thank you for watching. Bye-bye!